Saturated and unsaturated carbon compounds. Saturated carbon compounds have only single covalent bonds and unsaturated carbon compounds have double bonds or triple bonds between the carbon atoms. Generally, carbon forms a large number of compounds with hydrogen only, and those compounds of carbon and hydrogen only are called hydrocarbons. So, carbon compounds are saturated and unsaturated, and also hydrocarbons are saturated and unsaturated both. So, now we will discuss about saturated hydrocarbons, unsaturated hydrocarbons, that is the compounds of carbon and hydrogen only. As I have told you about hydrocarbons, now saturated hydrocarbons also you know, the compounds in which carbon atoms are linked only by single covalent bonds, and saturated hydrocarbons are called alkanes. Methane, ethane, propane, in which carbon atoms are linked with single covalent bond, like methane, CH4, ethane, C2H6. We can write the structural formula of methane. These are 4 valencies. These 4 lines indicate the 4 valencies of carbon which are satisfied by the 4 hydrogen atoms. Ethane, each carbon atom has 4 valency which are satisfied by the hydrogen atoms. So, this is structural formula of ethane, this is structural formula of methane. We can also write the electron dot structure of ethane. We have already discussed the electron dot structure of methane, and now we discuss the electron dot structure of ethane. We will study, earlier we discussed the electron dot structure of methane. As you know, there are 2 carbon atoms in ethane, its formula is C2H6. Each carbon atom has how many valency electrons? We can make it little closer, okay. And between the 2 carbon atoms, we can make this shared pair of electron. So, these dots indicate 4 electrons of each carbon atom. The electrons, valency electrons of hydrogen are shown with the crosses, just for the sake of distinction. So, all hydrogen atoms have completed their duplet, and each carbon atom also has completed the octet. Right. So, this is the electron dot structure of ethane, and now we move on through unsaturated hydrocarbons. Now, as you already know that unsaturated hydrocarbons have double bonds or triple bonds between the carbon atoms. Unsaturated hydrocarbons are alkenes, in which there is a double bond between the carbon atoms, and also called alkynes, in which there is triple bond between the carbon atoms. Alkenes like ethene, Example, ethene, propene. The first member of alkenes is ethene. Alkynes, C2H2, first member is acetylene, it is a common name, and ethyne or ethine, both are the names. Here also there are two names, ethene or ethylene. We will discuss just now after some times. Ethene or ethyne are the IUPAC names, whereas ethylene and acetylene are the common names. So, ethyne is the first member of alkynes, then followed by propyne, butane and so on. Now, we will discuss how to write the structure of hydrocarbons. Now, if you want to write the structure of carbon atoms, say butane you want to write. Butane has 4 carbon atoms. So, first of all you will make 4 carbon atoms by a single line showing single covalent bond, and then draw lines to show 4 valency of each carbon atom, and then satisfy all the valencies with hydrogen. So, like this we can write the structural formula of the hydrocarbons. Now, let us study about some of the members of saturated hydrocarbons, that is alkanes, in which there is a single covalent bond between the carbon atoms. Carbon atom is 1, the alkane, the first member of the alkane is methane and its formula is CH4 and its structure is carbon atom is 2, the second alkane is ethane and its formula is C2H6 and its structural formula is this. Number of carbon atoms is 3, then it is propane. Write the structural formula, 3 carbon atoms, lines to show the 4 valencies of each carbon, and then writing of hydrogen atoms. Let us write one more, butane. Four carbon atoms, then lines to show 4 valencies of each carbon atom, and then now you can see that in all these formula carbon atom is forming a straight chain. The chain is straight. The carbon chain can be branched also, it can form a ring also, it forms cyclic compounds also. So, let us discuss some of the cases in which carbon forms a branched chain. Let us take the case of butane. Already we have seen butane structure, the straight chain. Now, if it forms a branch, let us see what happens. So, you can see a branch, you can see yourself. Okay, then in the same manner we can write it like this also. like this to write more neatly, and then writing of hydrogen. Okay. Now, what similarity do you see between this and this? The structure is different, but see that formula, molecular formula of both is same. So, such compounds are called structural isomers. Structural isomers. So, structural isomers have same molecular formula, but different structural formula. This is called isobutane, and this is called N-butane. So, there are two structural isomers of butane. Now, let us see the structural formula of pentane, in which there are 5 carbon atoms. Pentane, let us write the structural formula of pentane. Straight chain, you should do the practice of writing the structural formula of the hydrocarbons. Now, let us make the branched structure. So, this is a branch structure. Another branch structure can be, let us see what it will be. So, you can see there are 2 types of branched structures of pentane. So, let us complete this formula. You make sure that 4 valencies of carbon should be satisfied in each case. And now this okay, and writing of hydrogen everywhere. So, you can see in all these 3 structures, what is the difference? This one is having a straight chain of carbon atoms, this one is having a branched chain of carbon atoms, this is also branched, much branched than this. So, these are 3 structural isomers of pentane. The first one is called N-pentane, the second one is isopentane, and the third one is neopentane. Same molecular formula, but different structural formula. So, this is about the branched hydrocarbons. Now, the ring type of compounds, in which the carbon atoms form a ring, like cyclohexane. So, here six carbon atoms, and so in each, you can see now in the ring 2 valencies of each carbon atom are satisfied. So, remaining 2 valencies are satisfied by hydrogen atoms. So, such type of compounds are called cycloalkanes, that is cycloalkanes in which there is only single covalent bond. So, it can also be cycloalkenes where there is one double bond, and cycloalkynes where there will be one triple bond between the carbon atoms. Now, let us take another compound benzene, in which the carbon atoms form a ring of 6 carbon atoms. So, you can see the formula of benzene is C6H6. So, you can see there are alternate double bonds between the carbon atoms, one double bond, one single bond. In each carbon atom you can see 3 valencies of each carbon atoms are satisfied, and one valency is satisfied by hydrogen atom. We can also write benzene like this by making a hexagon and showing the double bonds like this. This benzene and its compounds are also called aromatic compounds. See the electron dot structure of ethene C2H4. So, here a double covalent bond is formed by the sharing of 2 electron pairs, and both carbon atoms complete their octet, and hydrogen atoms also complete their duplet. Another first member of alkynes is C2H2, ethyne. Here a triple bond is formed between the 2 carbon atoms by sharing of 3 electron pairs, so that each carbon atom completes its octet, and the hydrogen atoms also complete their duplet. You do the practice of making electron dot structure of cyclohexane yourself. Functional group. Functional group. Functional group, let us first see the definition. Functional group is an atom or group of atoms which make carbon compounds reactive and decides its chemical properties. The element or a group of atom replaces the hydrogen atom and takes its place in the carbon compound. The element which replaces the hydrogen atom is called heteroatom. So, let us discuss some of the functional groups, because as in the definition we have seen, it decides the chemical properties of the carbon compound. So, some of the very important functional groups are: when a hydrogen atom is replaced by a halogen atom, it forms a halo group. Heteroatom is chlorine or bromine or iodine, it may be, or fluorine may be. The functional group is named as halo, and it is named as chloro-bromo, and the formula of the functional group is this. This is the formula. Heteroatom is oxygen, it forms a group of atom. Alcohol, the formula of the functional group is OH. So, all the alcohols have OH group in them. Hydrogen atom of an alkane is replaced by OH group and it forms the alcohol. Another functional group is aldehyde, and its formula is CHO. So, hydrogen atom is replaced by CHO in the alkanes. Another this also can be written as like this, CH double bond O. So, the 4 valencies of carbon are satisfied. Then ketone CO group. Now, this also should be written like this. Of course, CO also we write, but by this we can clearly show the 4 valencies of carbon getting satisfied. The fourth functional group is carboxylic acid. COOH. We can write like this also, we can write COOH also for the sake of convenience. Like this also we can write CO or COOH. Now, we will study about homologous series. Let us first of all study the definition of homologous series. Homologous series is a group of carbon compounds in which the compounds have similar structure and similar chemical properties, and the successive members differ by a CH2 group. Some of the examples of homologous series are alkanes, alkenes, alkynes, alcohols, aldehydes, carboxylic acid, all these form the homologous series. Like the first member of alkane is methane, CH4, ethane, C2H6, propane, C3H8. Now you will think ki how to write the formula of so many alkanes and so many alcohols. How to remember all these formula? But this is very simple, and it will become very easy to write various alkanes, alkenes, alkynes, alcohols, aldehydes or carboxylic acids. Simply we need to know the number of carbon atoms present in that compound. We can write the formula of that compound of a particular homologous series. So, for this we should know about the characteristics of homologous series. All the members of a homologous series can be represented by a general formula. Like, let us take an example, like alkanes can be represented by the general formula CnH2n plus 2. What is N? N is number of carbon atoms. So, you can write the formula of any of the alkane provided you know the number of carbon atoms. Suppose number of carbon atoms are 5. So, you can write the formula C5, and what will you write here? 5 2s are 10 plus 2 12. C5H12 will be the formula of the alkane having 5 carbon atoms. You need not to memorize all these formulas, simply you should know the first member, or simply you need to know in fact the general formula of that particular homologous series and the number of carbon atoms. So, by knowing the general formula and by knowing the number of carbon atoms of the organic compound, you are supposed to write the formula, you can write the formula. Alkenes, general formula is CnH2n. The first member is when n is equal to 2, because number of carbon atoms cannot be 1 in this particular case, because there is a double covalent bond. So, first member has 2 carbon atoms. So, the first member will be, you can see C2H4, that is ethene will be the first member. So, you can write any of the alkene by knowing the number of carbon atoms. If the carbon atoms are 6 in alkenes, it will be C6H12, 6 2s are 12. So, you need to remember the general formula. For alkyne, the general formula is H2N, CnH2n minus 2. In this case also, the first member of alkynes will have 2 carbon atoms. So, first member will be ethyne, CnC2H2, 2 2s are 4, 4 minus 2 will be 2. So, first member is C2H2, ethyne. So, you can write any member of this alkyne series provided you know the number of carbon atoms. Same way you can write about alcohols also, general formula, aldehydes also. Let us take the case of alcohol. The general formula is C2CnH2n plus 1 OH, right. If n is equal to 1, think over it. What will be the first member of alcohols? Let us write it here. N is 1, so we need not to write 1. H is 2 into 1 plus 1, 3. So, H is 3. So, first member is methanol, and same way you can write the second member also, third member also, but you should know the general formula. Same way for aldehydes. For aldehydes also, general formula is same. So, we will discuss all these in detail while discussing the IUPAC names. So, first very important characteristic is knowing of general formula. The second one is successive members differ by CH2 group and their masses differ by 14U. You can see the methane, ethane, CH4, C2H6. What is the difference between CH4, C2H6, C3H8? They all differ by CH2 group and the masses differ by 14 U or 14 AMU, atomic mass unit. All the members of the homologous series have similar chemical properties. Their chemical properties are similar, but they have different physical properties, because reason is the structure increases, number of carbon atoms increases, due to which the masses, molecular masses of these compounds increase, due to which the melting point, boiling point and density also increase. So, physical properties are different, but chemical properties are same. Nomenclature of carbon compounds. How these carbon compounds should be named? There are common names which may be different in different countries, but there are IUPAC names which are similar all over the world. So, same system is followed everywhere, and there are certain rules that we will discuss how to name the carbon compounds. Now, to name the carbon compounds, first of all write the structural formula of the carbon compound and identify the longest straight chain and count the number of carbon atoms. Say, so first of all identify the longest straight chain of carbon atoms. Let us say see this structure in which has a branched chain. So, you can see the longest straight chain has 3 carbon atoms. So, the basic carbon chain, this side also and this side also, there are 3 carbon atoms in the basic chain, right. So, like this we write the basic carbon chain, and then before the basic chain prefix has to be written, phrase before according to the rule, and after the basic carbon chain also suffix is written. Some rules will be followed. Phrase after. Suffix means phrase after, prefix means phrase before. So, as I told you, first of all we have to identify the longest straight chain of carbon atoms. If there is longest straight chain has only one carbon atom, the IUPAC, for IUPAC name we will write meth, 2 carbon atoms, eth, 3 carbon atoms, prop, 4 carbon atoms, but, 5 carbon atoms, pent, 6, hex, 7, hept, 8, oct, 9, non and 10, dec. In the alkane homologous series, this is followed by, this basic carbon chain structure is followed by ane, alkanes. Ane will be written. So, in the alkane series there is one carbon atom, it will be methane. If there are 2 carbon atoms, it will be ethane. Similarly, if there are 6 carbon atoms, it will be hexane. So, hexane, if you know what is hexane, if you happen to read anywhere about hexane, what will you do? What will you write? That is, it has 6 carbon atoms and it belongs to alkane series. So, you can write the formula, you can write the IUPAC name hexane. Just by seeing the formula or from the name you can write the formula. Okay. In alkene series, so after this basic carbon chain, in the case of alkanes, suffix is written ane. In the case of alkenes, the suffix is ene, right. Ethene, ethene means eth for 2 carbon atoms, ene for double bond. So, ethene belongs to alkenes, unsaturated hydrocarbon. Now, if you happen to read anywhere propene, you will immediately come to know that propene has 3 carbon atoms and there is a double bond also. You know the formula also. Propene general formula is CnH2n. So, the molecular formula will be C3H6 and you can write the structural formula also, it will have a double bond. So, its IUPAC name will be alkene, ethene, propene, butene, pentene and so on. Alkynes, triple covalent bond is present between the carbon atoms and suffix is ine. So, the first member of alkyne will be ethyne. Ethyne immediately tells that there are 2 carbon atoms and there is a triple covalent bond and its formula will be C2H2. So, you can write any member of the alkyne series probably provided you know the number of carbon atoms. You can write the formula, you can write the structural formula and you can write the IUPAC name of that particular compound. Here you can see what is the IUPAC name of this compound. There is a triple covalent bond and the longest carbon chain is of 1, 2 and 3 carbon atoms. So, the basic carbon chain, the basic structure in the center will be prop followed by the suffix ine, propyne, it will be propyne. Let us take this example. There is a double bond, so it belongs to alkene series and the straight carbon chain has how many carbon atoms? 4 carbon atoms. So, it belongs to alkene series and the basic structure is but, which stands for 4 carbon atoms and followed by the suffix "ene", and this is propyne. So, we know about alkanes and alkynes, and let us study about the other functional groups like halogens. Halogens, all of you know, are fluorine, chlorine, bromine, iodine, which replace the hydrogen atoms in the carbon compound. And here the presence of this halogen group will be indicated by the prefix chloro, bromo. In this case also same procedure will be followed. First of all, identify the longest carbon chain, and the basic structure has how many carbon atoms? Count 1, 2 and 3. So, prop. All bonds are single covalent bonds, so it is ane for alkanes, right, and there is a chlorine atom which will be written as prefix. So, the IUPAC name of this compound is chloropropane. If in place of chlorine there is bromine, it will be bromopropane and so on. So, same type of rules are followed in each case. Another functional group is alcohol. You all know alcohol stands for OH. Here suffix OL is used. The rule followed will be again the same: identification of the longest straight chain of carbon atoms. How many are these? Start counting with me: 1, 2, 3, 4. So, the basic structure is but, 4 is for but. Then all single covalent bonds, so it will be butane, but E, in place of E we will write OL. So, it is what? Butanol. IUPAC name of this structure is butanol, C4H9OH. Aldehyde, the suffix -al is used. Now, in this case also the same, the number of carbon atom is 1. You will say there is a double bond, but this double bond is not between the carbon atoms, but it is the double bond in the functional group. So, it is a saturated compound only and not an unsaturated compound. So, what is the name of this? One carbon atom means methane, and E is replaced by what? Al, methanol. So, its formula IUPAC name is methanol. Here let us see another example. See the number of carbon atoms, 2. So, all single covalent bonds, so it is ethanol. So, like this you can write the IUPAC name and do the practice of writing more of the IUPAC names. Another functional group is ketone. Here the suffix is -one, and the rule is same: identification of the straight chain of carbon 1, 2, 3. So, count it first of all. So, 3 carbon atoms means prop. So, propanone, no double bond is in the functional group. So, this does not make the compound saturated. So, the compound is propanone, -one, suffix is -one. Next functional group is carboxylic acid, and here the suffix oic acid is used. Identification of the straight chain, only one carbon atom, and so IUPAC name will be methanoic acid, right. Another example, 2 carbon atoms. So, carbon atom of this functional group also will be counted. Do not forget to count this carbon atom also. So, the main substance will be ethan stands for 2 carbon atoms, ethanoic acid, right.